Hello friends, in this video we are going to discuss the previous year GATE question number 40. This question is from GATE 1998 examination. Let us read the question. A three-phase fully controlled converter is feeding power into a DC load at a constant current of 150 ampere. Okay, so it is given that the load current is constant. So I0 equal to I0 is equal to 150. Next, the RMS current through each thyristor of the converter is, and they have given the four options. So it is a fully controlled converter we are having. Okay, so if you check or if we draw the fully controlled converter, that is nothing but the fully controlled rectifier, the waveform, it will be the circuit diagram, right? It will be like this. We are having the six thyristors. As the load current is constant, so definitely the load, yes, it will be the REL load. Type of circuit will be having the load is R capital I Z, constant load current. Thyristors we are having input is three phase AC supply. Three phase AC. Thyristors are T1 by 4 AC T2. And this type of numbering only we have given. So our task is to find the RMS current through each thyristor. Okay. So let us let us draw the waveform for the current flowing through the thyristor T1. Okay, current flowing through thyristor T1. So if you check here, we are having the I0 waveform. It is a constant current, right? I0 is a constant current. So omega T 0 I0. This is a constant current of 150 ampere, right? So I0 is the constant current that is equal to I0. Okay. So now we are going to draw the waveform of the thyristor current IT1. Okay. So if you check the circuit operation, so we check the circuit operation. Okay. Thyristor T1 in the three phase 6 pulse converter or three phase full wave rectifier, we are having six switches. At a time, two switches will be in the on state, one from the upper group, second one is from the lower group. Okay, and each thyristor, yes, will be conducting for 120 degree. Okay, so here suppose thyristor T1, as we know thyristor T1 is in the conduction mode from pi by 3 plus alpha, right? Pi by 3 plus alpha, suppose this is the pi by 3 plus alpha till pi plus alpha, till pi plus alpha. Okay, so during this interval of 120 degree, thyristor T1 will be in the on state. Okay, and in pi from pi by 3 plus alpha to pi plus alpha. Okay, this thyristor T1 will be in the conduction mode, right, with a in pair with a thyristor T6 as well as in pair with a thyristor T2. Okay, so out of this 120 degree, out of this 120 degree, for first 60 degree, for first 60 degree, thyristor T1 will be in the on state, yes, in pair with a thyristor T6, and after that with a thyristor T2, with a thyristor T2. So when T1 and T6, when T1 and T6 will be in the on state, at that time IT1 is equal to I0 only. Okay, and at the same time, suppose when T6 is in a off state, suppose when T6 is in a off state and when thyristor T2 is turned on, okay, at that time also the current flowing through thyristor T1 is equal to, yes, IT1 is equal to I0 only. Okay, so waveform for the current IT1, it will be like this only, right? Waveform for current IT1, it will be like this. Okay, this magnitude is same as that of the load current, that is the I0. Okay, now this will be for one cycle. Okay, so this is for 0 to 2 pi. Okay, and it will be in conduction mode from pi by 3 plus alpha to pi plus alpha. Okay, pi by 3 plus alpha, sorry, pi plus 3 nahi, pi by 3 plus alpha to pi plus alpha. Is this clear? This is from pi by 3 plus alpha to pi plus alpha. Is this clear? Okay, so out of that pi by 3 plus alpha to pi plus alpha, yes, thyristor T1 will be in pair with the thyristor T6, okay, till 2 pi by 3 plus alpha. And after that, from 2 pi by 3 plus alpha to pi plus alpha, this will be thyristor T1 will be having the pair with the thyristor T2. Okay, so next, so for this waveform, can we derive the expression for IT1 RMS? Yes, IT1 RMS is equal to, if we check, it is equal to 1 by 2 pi integration from pi by 3 plus alpha to pi plus alpha, pi by 3 plus alpha to pi plus alpha. Yes, value is I0 square into d omega t, the power 1 by 2, the power 1 by 2, right? So here we can write it as square root of mean of squared value. So we can write it as I0 divided by root 2 pi. Okay, I'm taking I0 square outside as well as 2 pi outside. Okay, so it is like integration of 1, that is the omega t, limit pi by 3 plus alpha to pi plus alpha, right? And to the power 1 by, okay, so if we further simplify it, it is equal to I0 upon root 2 pi into, yes, it is like pi plus alpha minus pi by 3 minus alpha, pi plus alpha minus pi by 3 minus alpha, the power 1 by, plus alpha minus alpha will get cancelled. Okay, so it is like pi minus pi by 3, so it is a 2 pi by 3, it is a I0 by root 2 pi into 2 pi by 3, the power 1 by 2. Okay, so here root 2 and root 2 pi it will get cancelled, so it is like I0 by root 3. Okay, so it will be like I0 is 150, so you can write it as 150 by root 3 ampere. Okay, this is the IT1 RMS, right? I0 is a 150, so therefore it is a 150 by root 3, 150 by root 3. So if you check, the correct answer is option D. Option D is the correct answer. Is this clear? This is a very simple. Here we need to understand how to find the value of current flowing through thyristor T1. Okay, any thyristor you can consider. Okay, so I have considered it as a thyristor T1 current, IT1 only. Okay, because they have asked for the RMS current through each thyristor. Okay, so any one thyristor you need to consider, right? Next, so this is about the question number 40. In the next video, we are going to discuss the question number 41. Thank you.